All right, so for the second part of the worksheet for number 3, we were given some graphs and we had to find the zeros and then identify whether the graph was touching or crossing, which will tell us what the multiplicity is. So here we can see the zeros were at -3, 2, and 5, and I've identified whether the graph is touching or crossing at each point. Again, if your graph is crossing, it's going to have an odd multiplicity. If it's touching, or if you want to refer to as bouncing, it's going to have an even multiplicity. And the same thing down below, we've got our zeros, and I'm identified whether they are touching or crossing, and identified what the multiplicity is going to be, even or odd. Now, just to take things a step further, if you notice here, let's look at what the ends of the graphs are doing. I know I didn't ask this, but I do want to talk through it. Do you see how both ends of the graphs are pointing up? Now, since the ends of the graph are going in the same direction, so they're going in the same direction, that means that we're going to ultimately, this function has an even overall degree. So I've written this out to the side. So since both ends are going in the same direction, we have an even degree. And since they're both going up, that means that we have to have a positive leading coefficient. Okay, the same thing applies with this second graph, but it's the same thing. Both ends are going up. That means we have to have an even degree, and then because they're both going up, it's going to be a positive leading coefficient. All right, so we're going to switch back over to the notes and pull all of this together. So we have talked about, and I've used some of these words. I haven't used the word solution yet, but I have used roots and zeros and x-intercepts, and we've also talked about factors, and these all relate to one another. So first of all, if you're given a polynomial or an equation and you solve for x, you have found a solution. And a solution is the same thing as a root. And when we are talking about polynomials, we find this by setting our function equal to 0, right? And we solve. And say, for example, we end up getting x equals 2. Okay, maybe that's just our example. So when we solve that, that is telling us what our x-intercept is. And so we can use the knowledge that x equals 2 to know that our x-intercept is really at the coordinate 2, 0 of our graph. Now, we also could use that x equals 2 just to say that it's a 0 of the function. Okay, and we could determine its multiplicity, whether it's touching or crossing, and all of that. Now, if we are just told that x equals 2 is a 0, we could work backwards and know that x minus 2 has to be a factor. You're just doing the opposite sign of whatever your 0 is to get to your factor. Okay, so let's use all this information to put it together. And you'll notice that much of what we have here is already written down here for you, but I do want to touch base on a few things. So let's touch base. I'm going to erase some of this stuff that I have here, and we're going to go through it. Okay, so they give us this function, and it's already in factored form. So we first want to figure out what our degree is. So here we know the degree of this term is 2. The degree right here is not written, but the degree there is just going to be 1 as well for that factor as well. So we're just going to add our exponents together to get our overall degree. So our degree is going to be 4. And then we want to look at our the sign of our overall polynomial, and our sign is negative. So because our degree is even, that means both ends are going to go in the same direction. And then because our sign of our polynomial is negative, that means that they're both going to go down. So we had an even degree and a negative out in front. So that means our graph is the ends of our graph are going to look like that. We don't know yet what's going on in the middle, but we know the ends are both going to go down. So then we want to look at our zeros. We can set each factor equal to 0 to find our zeros. So we know x equals 3, x equals -2, and x equals -1. Now, if we look at the 0 where x equals 3, we see that our multiplicity is 2. Now, because the multiplicity is even, that means that our graph is going to touch or bounce. Now, if we look at the 0 of x equals -2, our multiplicity is 1, which is odd, which means our graph is going to cross. And then lastly, at our 0, x equals -1, our multiplicity is also 1, which means our graph will cross at that point as well. Now I know you're looking right here and you already had, I'm going to erase some of this because I'm going to go through how I would graph this if this was me. So we know that at -2 and -1, our graph is going to cross. So I'm going to kind of just mark that it's going to touch. Excuse me, that it's going to cross at those two. Now out here at x equals 3, we know it's going to touch, but we don't know if it's touching right there or if it's touching right there yet. We don't know that yet. Okay, so I'm going to hold off. I just need to keep in mind that it's going to touch there. Now I know that my graph is going to start going down, right? And when you graph this, you kind of want to go slow, but just have a smooth curve. And we know our graph's going to end up going down over here. And sometimes I'll just do this because I know that's going to happen with end of my graphs. So it's going to start down. It's going to go to this right here at -2, and I know it's going to cross. So it's going up. I don't know how far it's going up, but I'm going to have to turn and come back down because I know it's not going to hit the x-axis again until they're at -1. So it's going to cross there at -1, and it'll come down somewhere. We don't really know exactly where, and it's going to turn back. And over here at x equals 3, remember it's going to touch. So I'm going to bounce that around and come here. Okay. I know it's not the best looking graph, but I wanted to walk you through how I'm doing it. Now your graph may go way up here, and that's fine. Or maybe your graph didn't go quite as far and just went down right there. That's fine as well. The big thing that I wanted to notice is that you've got your zeros in the appropriate place, that they are touching or crossing depending on what the multiplicity has told you, and that your end behavior is going in the correct direction. Okay. Now we're going to look at one more example before you go practice on your own. So here, if we take a look, we're given a graph. And as we're given the graph, what you want to do is look and see where your x-intercepts, your zeros are, and figure out if it's touching or crossing. So we see we have a 0 at x equals 4, and we see that our graph is touching. So that means it has to be a even multiplicity. And if we look over at x equals 0, we see the graph is crossing, which means it has to have an odd multiplicity. Now I did over here at the side, if I know my 0 is x equals 4, my factor is just going to be x minus 4. And if I know my 0 is x equals 0, my factor really is just going to be x. Okay. Now you'll notice if we look at the end behavior, we notice that the graph is going up on the left-hand side and it's going down in the right-hand side. Now, because my ends are going in opposite directions, we know that we have got to, our overall degree has got to be odd because they point in opposite directions. And you notice that overall my graph is decreasing or going down, right? It's starting up and it's going down. And so that's telling us that we have a negative in the outside of our polynomial. So we keep that negative here. We pull our first factor, which is just x. And because it had an odd multiplicity, we're just going to leave that raised to the power of 1. We don't actually have to put that 1 there, or you can if you want. And then we have our next factor, which is x minus 4, and it has to have an even multiplicity. And I'm just going to raise it to the lowest even multiplicity, which is just 2. And so this is our final function, negative x times x minus 4 in parentheses squared. Okay, so I want you to stop now and go and do the last problem on the worksheet and come back and take a look at the answers. All right, so this particular equation, I noticed that it was negative out in front and that the overall degree, I just added those exponents, my overall degree is 3, which is odd. So it's negative and odd. So I know that this is the overall shape that my, or direction that my end behavior should be. So I know that this should be going, starting up, and then ultimately my graph is going to be decreasing and going down. Now I found that I had zeros at x equals 1 that had a multiplicity of 1, which means it's going to cross there. And here I had x equals negative 3, which with a multiplicity of 2, which means it's going to touch or bounce. So you'll notice I started my graph up high. I came down to my 0 at x equals negative 3, and I touched or bounced. And then I went back up and came back down at negative 1 and crossed. So everything checks out right. We see that my overall graph is decreasing, right? It starts up high and goes down. We see that it bounces or touches here at x equals -3 and crosses at 1. Now your graph may look slightly different. Maybe you pulled this way up high right here before you came down. That's totally fine. Or maybe you decided to only have it go up a little bit like that. Totally fine as well. We'll talk a little bit later about how we can make our graphs a little bit more exact using a y-intercept, but for right now, you're just trying to get a general sketch. This is not an exact graph, it's a general sketch of what this polynomial looks like. Now in part B, we were given some information and had to actually write the equation of the polynomial. Now they tell us it's negative, and hopefully you thought, all right, I don't want to forget about that. Let me go in and put that negative out in front. And they told us it's an even degree. I didn't have to do this, but I did go on and just say what this graph is going to look like. And then they told us some information about the zeros. They told us that at x equals 4, it's going to cross, and at x equals -3, that the graph crosses. And so that's telling us that those both have odd multiplicity. And then lastly, over here, we're told that the graph touches at x equals 1, which has given us even multiplicity. And you'll notice for each one of these zeros, I wrote what the factors are, just to help me before I put everything together for my equation. So I remembered to pull out my negative, and then I have my factor x minus 4. Remember, this is an odd multiplicity, so I'm just going to leave that raised to the first power. And then I have my next factor x plus 3. Again, it's an odd multiplicity, so I just left that raised to the first power. And then our last factor, x minus 1, it has an even multiplicity, so I just raised that to the second power. Now we can double check everything because we're expecting the overall degree to be even. And let's see, we have 1 plus 1 plus 2, which equals 4. The overall degree here, so the overall degree is 4, which is even. So that matches what we were looking for overall. And that's the equation of your polynomial.